Hello friends, myself A.T. Motiani, professor at LA College Morbi in Civil Engineering Department. I am here to give the information or cover the chapter which is the building planning. It is the part of the subject elements of civil engineering of semester 2 in the GTU syllabus of semester 2 of the civil, and it's also offered to all other branches also. We have already covered the different topics in this chapter. In the first lecture we have covered the planning of the building. Then in the next lecture we have discussed the principles of the planning, and in the third lecture we have already covered the planning requirements of the building. Now in this lecture, this is the fourth lecture in this series of the chapter building planning, we are going to discuss the civil engineering drawing. Now let us first see what is the drawing, then we will see what is the engineering drawing, and then we will discuss what is the civil engineering drawing. Now drawing describing any object information diagrammatically is known as the drawing. Engineering drawing graphical means of expression of technical details without the barrier of a language. Drawing can be called as a universal language for engineers. The diagrams, sketch, pictures are used for the communication. Communication means from one department to other department, from one person to other person, from one engineer to other engineer. We have to convey the different details of the project or the building or the machine or the equipment which we are going to manufacture, the type of the material we are going to use, size of the components that we have to communicate. Without the graphical picture, using only the words, it is very difficult to explain the details of the project or equipment. So you can see here the photograph of a small lightweight multi-role supersonic compact aircraft. So the graphical picture itself is self-explanatory to convey the information to other person. Similarly here this Airbus A380, the largest passenger jet, 80-meter wingspan, and tells that it stands as high as a 7-story building, carries more than 550 passengers. So only words cannot give the idea about the greatness of this plane, but along with these words, if we put the picture of this plane, can give the clear idea about the aircraft. It would be impossible to communicate all the necessary details about this aeroplane verbally in writing. So drawing is useful. A picture drawing is worth 1,000 words. So if any drawing is there, it is more than the 1,000 words of the description of that particular project or the equipment. Drawings are the roadmaps which show how to manufacture products and structures. So this is a building, drawing of a building, which is impossible to describe the details of the building in the words. Even a whole dictionary will be not sufficient to describe this any structure or any equipment. So similarly here this is a mechanical instrument, there is a lathe which is the drawing is there. Then similarly here this is a chemical reactor used by the chemical engineers. This is the electrical circuit used by the electrical engineers. Drawing is important for all branches of engineering. It is not only for the civil or mechanical branch, it is useful to each and every branch of engineering. Graphical representation of an object is a drawing. Engineering drawing means a drawing of an object that contains all information. Engineering drawing means it contains all the information about each and every part of the equipment or the building, its shape, its size, then material used, then method of manufacturing, everything is explained in the drawing. So no construction or manufacturing of any man-made engineering object is possible without engineering drawing. So these are the different aspects of the engineering drawing. You will learn how industry communicates technical information using the drawing. Then visualization. Visualization is very important aspect in the drawing, because engineers are going to manufacture or construct the structures which are not existing, but they have to visualize that how they will look, how they will perform after their construction. That visualization is necessary at the beginning of the at the stage of conceiving that structure. So then only the end product will be perfect. Then graphics theory, geometry, projection techniques, everything is very important to prepare the drawings. Then standards. Standard means the procedure or the technique or the symbols are made standard to make the drawings universal. Like the symbol of the brick masonry is the same everywhere, or this symbol of the exhaust fan, it is the symbol of the exhaust fan is the same in every country all over the world. So whenever any person is reading the drawing and the symbol is there for the exhaust fan, he will easily understand this is the exhaust fan. So this standardization is done by the Bureau of Indian Standard, BIS. Then the conventions is some practices, how to draw the lines, what should be the thickness of the line, where we have to use the dotted line, where we have to use the cut line, or we have to use the thin line. Then the tools, which are the drawing tools, how they are used, that is also necessary for the beginners. So in the first year you are just taken the admissions, so you may not be conversant with all types of different tools and drawing tools and equipments used for the engineering drawing. So we will go through all those tools also. Then application, the various uses of technical drawings. So what is the application of different types of drawings? There will be different types of drawing. In our previous lectures we already discussed different types of drawings. In that we have seen this orthographic plans, orthographic views, isometric views, perspective views. So these are the different views, and each and every type of view has got different application. Engineering drawing is completely different from the artistic drawing. Artistic drawing means the artist who are drawing some scenery or some picture of the nature, like that. So that is totally different from this engineering drawing. They have got some different purpose. They have got some philosophical object to convey the message to the viewers. But in engineering drawing we have to construct the structures. So our purpose is different. So we are interested in the size, material, and the construction method also. So engineering drawing is totally different from the artistic drawings. So engineering drawing can be prepared in two different ways. One is the manual drawing. When the computers were not invented, the only option left was to prepare the drawings manually. But now, as you know, the computers are having the wide utility in different areas of engineering. So here in the drawing also, the computer aided drawing and design softwares are available. For example, this AutoCAD is there. So many students may also be conversant with the AutoCAD. So they will feel that why we should use the manual method, why we should use the pencil and paper when we can prepare the drawings using AutoCAD. So they may be wrong. The reason is the Computer cannot replace the drafting board and equipment as learning tool. Once you have learned the basics of mathematics, now after class 12, you are allowed the use of calculator and computer. If basic fundamentals are clear, better use can be made of the power of the software. Okay, so we should know the basic principles or basic fundamentals. Then it will be very using the software will be more beneficial. If fundamentals are not clear, directly we use the softwares, then how the softwares are working, that will be very mystery for every engineer. To be an expert in technical drawing, this drawing is first step. Now these are the drawing tools, different drawing tools. The first is the drawing board. The wooden board is there, which is having the horizontal surface, and over that you can put the drawing sheet or drawing paper. Usually we use the drawing sheet, which is having a greater thickness more than the normal paper we are using. Then the drawing sheet, there are different sizes of drawing sheets are used depending upon the purpose of the application. Then mini drafter, drafting machine, or T-square. So mini drafter and T-square is used by the students. Either you can use the mini drafter or you can use the T-square, but professional architects will always use these drafting machines. Then instrument box containing compass, divider. At the school level in the geometry, at the standard 7th, 8th, 9th and 10th, you must have used this compass and divider, protractors. All these equipments will be useful here also. Then different types of scales are available. Either you can use the scales, or you manually convert the actual ground distance into the paper distance. Okay, so a scale is nothing but it's the ratio of the paper distance to the ground distance. So whatever ground distance is that first we have to convert into the paper distance using certain scale, and then we have to draw the line joining those 2 points. Then protractor is used to draw the lines at particular angle. So the angles for example, which are more frequently used, like 30 degree, 60 degree, 45 degree, 90 degree. For that you can have the triangles, or which are known as set squares. So set squares can be used, but for the odd figure of like say 23 degree, so you may use the protractor. Then the French curves, for joining the lines with smooth curve, we may use the French curves. Then drawing pencils. So normally at the school level, the pencil you are using was of the type of HB, but for architectural purpose or for the drawing purpose, the darkness or the quality of the lead which we are there in the pencil, there's a dark black lead, is varying from the H1 to H5 and B1 to B5. So B1, B2, B3, B4, B5, as we increase the number, the softness of the lead will be increasing. So B1, B2, B3, B4 these pencils are used for the shading purpose, and for particular drawing, the H1 or H2 is recommended. Then eraser, for any lines which are not required, maybe drawn by mistake or maybe drawn for some other purpose, are required to be erased. The rubber is used to erase those lines. Then drawing clips, to fix the drawing sheet on the drawing board, the drawing clips are used. Either drawing clips may be used, maybe pins or adhesive tape may also be used. Then sharpeners, to make the pencil's lead point very sharp as per the requirement of the thickness of the line, we may use the sharpener. Then duster is to clean the surface of the drawing sheet, or the front face of the pencil also is to be cleaned, so that the lead powder which is attached with the pencil is not transferred to this white surface of the drawing sheet, leaving unnecessary or undesirable stains on the drawing sheets. So this is the figure of the drawing board. As the drawing board is always having the working edge, so whenever the drawing is to be started, we have to keep the working edge on the left side of the user. Then these are the different sizes of the drawing boards. So B0, B1, B2, B3. So the drawing sheets also are having the similar size A0, A1, A2, A3. B0 size is used by the professional architects, but for students' careers, they may use only B1, B2 or B3. Similarly, the size of the different sheets, drawing sheets are having the size A0, A1, A2, A3, A4, A5. So A0 is the largest size of the drawing sheet. If you cut the A0 sheet in two equal parts along the longest dimension, that is a 1189 mm. Okay, so you will get the two sheets of A1 size. Again, if you cut the A1 size sheet in two equal parts, you will get the A2 size sheet. Similarly, if you cut the A2 size sheet, you will get the A3 sheet. Similarly, A3 sheet is cut in the two equal parts, you get the A4 size sheet. And again, if you cut the A4 size sheet in two parts, you will get the two A5 sheets. So this normally paper which we are using, this paper is A4 size. So if you double this, it will become the A3. Again you double it, it will become A2. Again you double it, it will become A1. Again you double it, it will become A0 size sheet. So this is a mini drafter. Many students prefer to use this mini drafter. Either you have to go for the mini drafter, or you can, if you don't want to use the mini drafter, you have to use the T-square. So this is you see the structure. This is a clamp where they used to fix the drafter on the drawing board, and these are the arms, and this is the protector, and these are the two scales at the 90 degree. Okay. So this is very convenient, and drawing can be made very fast. Okay. So drafting machine is the very large size equipment, and this is called the mini drafter, and many students are preferring this mini drafter over T-square because of the conveniency and easy workability of the drawings. So this is how it is fixed on the drawing board. This shows, so this is a drawing board, and this is drafter is fixed. This also you can see. So this is how we can set the drafter, and beneath that drawing drafter we have to fix the drawing sheet, okay, so where we can put the lines and put the draw the plan section and elevations of the buildings. So the alternate of the mini drafter is the T-square. So along the T-square you have to use the set squares also, or the set of two triangles. One triangle is having the one angle equal to 30 degree, another angle will be equal to 60 degree, and third angle will be equal to 90 degree, and another triangle will having the two angles equal to 45 degree, and another angle will be 90 degree. So these are the different, these are the two triangles, these are the protector, and these are the drawing clamps, and these are the French curves. So how this shows how this is the working edge of the drawing board, and again this T-square is having the working edge. So working edge is we have to slide this set square on this working edge. So you can have the parallel lines here using this working edge of the set square. So this is a protector that you can use. Now here the layout of the drawings. Now we will be focusing only on the civil engineering drawing. In any civil engineering drawing, we use, suppose this is a drawing sheet. This is the drawing sheet where we have to put the drawing. So normally on the left bottom corner of the drawing sheet, we will be drawing the plan. We will be drawing the plan Okay, so this is the plan, and here we will be drawing the elevation. And here we will be drawing the sectional elevation. So in this way, here we will be putting the north direction. Okay, so we can have this north direction, and there should be the margin. Before starting drawing, we have to put the margin on the left side. We have to put the line parallel to the edge of the paper, and leaving this margin width should be equal to 40 mm. On remaining three sides, we will be leaving this margin. So this margin will be equal to 10 mm. This means 40 mm means this space is equal to 4 centimeter, and this margin is left. This is equal to 1 centimeter, and at the right bottom corner we will have the title block. So this is the layout of the working drawings, or we can say this is the layout of the architectural drawings. So these are the margins we already discussed, 40 mm on the left side, because there will be several sheets. So we have to bind those sheets. So that for that reason we are leaving more space or margin on this left side of the drawing sheet, and on the remaining three sides we are leaving equal margin, that is a 10 mm, 10 mm, and here also it will be 10 mm. So remaining three sides we will be leaving the 10 mm margin, and on this one side we will be leaving 40 mm margin. Then what is the importance of title block? And title block, size of the title block also varies. First we discuss what is the importance of this title block. So title block will show the there will be two aspects. One is the at the educational level. That means you are as a student, how you will be using the title block, and after you do the completion of your graduation, you start your own office. Then in that case, how you will be using this title block. So as a student, you will be using this title block to mention the title of the sheet. It is pertaining to what, whether it is a residential building, public building. Okay, then what is the scale you have used, then what is who has prepared this, that means the name of the students, his roll number, like that, and the faculty or professor who will be checking this will be put his remarks in this title block. Okay, so this is at the educational stage, but in the professional architects, they use this title block to put their name of the company who is preparing this, date of the preparation, which employee or which engineer has prepared it, name of that engineer, and date of submission to the proper authorities, on which date it has been submitted for the approval of the construction, where it is to be submitted, whether it is to the urban development authority or corporation. Then after submission these drawings to the corporation or urban development authority, they will issue the permission of the construction. So they will also put the signature or permission certificate in this title block. They will signing this, and they will approve this drawing, and they will issue the certificate for the permission of the construction of the structure. So these are the two different aspects. One, what should be the size of the title block? If the sheet is having the larger size, then the title block also should be having the larger size. If the sheet is smaller size, the title block also should be of a smaller size. So in A1, A2 size sheet, it should be 15 centimeter by 10 centimeter, and if the sheet is smaller size, that is the A3 or A4, then the title block may be the 15 centimeter by 5 centimeter. So this is the 15 centimeter and this is the 10 centimeter, and accordingly, as per requirement, you will divide this space to mention the different things in this title block. So any civil engineering drawing means we are going to construct the structure, maybe the buildings, maybe the structures other than building, that like the dam or roads or railway tracks or the ports. So without north direction, there is no meaning of any drawing. So all the structures are oriented with reference to the north. In our previous lecture also, we have seen the what is the importance of the north direction, because in any building, if we want to study the quality of the building, whether it is will be having the good environment or not, so we see the different directions of the building, and the sunlight or wind direction coming inside the building is with reference to this north, east, west and south directions. So every civil engineering drawing should have the north direction. The location of the north direction is always on the right hand top corner. So this is the location of the north direction, and there are different various styles of drawing the north direction. The simplest of the all north direction, the simplest is you draw a circle of 3 centimeter diameter. So this diameter is 3 centimeter. So now then you decide what is the direction of the north. It is not necessary that always it will be on the top. It may be any direction. It may be this direction. It may be this direction. Suppose this north is in this direction. Okay. So what you will do, you put the point here. Okay, and then draw a dotted line, okay, diameter, and then you draw another dotted line perpendicular to this, and then this north direction which is there, you join this line. Now this line is 3 centimeter, length of this diameter is 3 centimeter. So 1 centimeter you draw the full line. On this side also you draw the 1 centimeter full line, and have the tail of the arrow like this. Okay, you can complete this north direction. So other ways of drawing the north directions are, you can see here. Okay, the north direction here. You can show the wind direction also. So which in earlier lectures we have discussed the direction of the wind. In the summer it is always from the southwest to northeast, and in the winter it is from the northeast to, it's in the reverse direction in the winter season. Now scale we have already discussed. What is a scale? A scale is the ratio. Scale is the ratio of paper distance to ground distance. Now on this paper we are going to represent a large size building. Okay, so building size may be say 4 meter by 4 meter room, and our drawing sheet size is only say 30 centimeter by 45 centimeter. So we have to convert that actual ground distance to smaller size so that we can accommodate that drawing in our drawing sheet. So as per our drawing sheet, we have to choose proper drawing scale. If our drawing sheet is say of A3 size or A2 size, and if we choose the scale of 1 centimeter equal to 50 centimeter for a 2 BHK or 3 BHK house, then our paper size will not be sufficient to accommodate the whole drawing. Okay, so we have to see what is the size of the drawing sheet and what is the size of the structure and what should be scale. In the building, what is the largest size of the wall or side of the building, that you find out, and you try these different scales, convert it into the centimeter, and see whether you can accommodate that drawing in your drawing sheet or not. Okay, that is the way to decide the scale. Usually for submission of the drawings to the authorities, we can, for working drawings, we can choose the 1 centimeter equal to 200 centimeter, or 1 centimeter equal to 100 centimeter, or 1 centimeter equal to only 1 centimeter equal to 50 centimeter. So these are the three options with us. We cannot decide any scale. We cannot say that I want to submit the drawing in 1 centimeter equal to 120 centimeter. So authorities will not accept this. They will not accept this scale. So because the reason is, if you draw the drawing plan section elevation in this type of scale, it is very, very difficult to read this drawing. It is very easy to read the drawing if it is drawn in the scale of 1 centimeter equal to 100 centimeter, or it is drawn in the 1 centimeter equal to 200 centimeter. So ways of mentioning the scales, there are two different ways. Either you mention is equal to 1 centimeter equal to 1 meter. So on both the sides we have mentioned the unit. On this side is the 1 centimeter is equal to 1 meter. Or you convert on both the sides having the same unit. Okay, so also centimeter, on this side also centimeter. So this can be written as 1:100. Okay, so that is the two different methods of representing the scale. So if the area is very large, is a map of a large area, layout of a large township, in that case you may have the larger scale, that is a 1 centimeter equal to 1 kilometer, or 1 centimeter equal to 1 centimeter equal to 10 kilometer, depending upon the size of the land area which is we are going to develop, and the size of the sheet is available with us. Now the different types of lines which we will be using in this drawing, there will be different lines, diagrams in a single sheet. One diagram may be here, another diagram may be here. So to separate these diagrams, we may draw a line to separate these diagrams. So the lines used for separating the diagrams will be having the thicker size, that is 0.6 or 0.8 or 1 mm. Then we have to mention the dimensions of the rooms or size of the buildings or walls. So we have to draw the dimension line. So thickness of the dimension line may vary from the 0.2 mm to 0.3 mm. Then hidden lines. Sometimes we have to show the components which are not directly visible. They are not in the view, but they are to be shown in the plan. Okay. So that is called the hidden objects. So hidden objects are drawn by dotted line. Suppose in the flooring, suppose this pipeline is there. Okay, we may show the pipeline which is beneath this flooring. Okay, there is a floor in the room, the flooring is there. Beneath the flooring, the pipeline is there. So pipeline is not visible, but it is there, it is hidden, so we may draw it by dotted line. Then the central line of the beams, central line of the walls, central line of the foundation, these are drawn by the central lines. And the central lines are full line, then dash line, and thickness should be 0.2 to 0.3 mm. Then cutting lines, or we may call it as section lines. Section lines are drawn with the this line 2 dash, and should have the thickness varying from 0.6 mm to 1 mm. Then break lines. Sometimes the structure component is having the large size. If we draw the full size structure in the drawing sheet, then it may happen that our drawing sheet may not be able to accommodate that. then we may have to use this break line. So break line for the short break, this is a break line for the short break. So thickness varies from 0.6 to 1 mm, and this is the break line for the long break, it varies from 0.2 to 0.3 mm. So size of the lettering in a drawing sheet, you are going to complete these drawings, that is the plan, section and elevation. Okay. So you have to mention the different details of the components of the building, like the flooring, foundation, what is the thickness of the slab, what is the lintel, what is the thickness of the lintel, what is the room size. So we have to use the alphabetics and numerics to mention the size, type of material, then this shape of the material, all these details we have to show. But to mention the type of the material and its size, we use the alphabetics and numerics. So in any drawing sheet there will be three types of lettering. One is the title of the sheet, that will have the letter size of the largest size. So we may put this is a residential building, so this is the title of the sheet. So letter height will be having the largest size, residential building. So this letter height letter size is mentioned or specified by this letter height. This height should be 7 to 10 mm. So this is a title, like in our book the chapter is there, the title of chapter will having the largest size. Okay. Then this plan, so plan is the subtitle, so the size of this height of this letter should be smaller than this title of the sheet. So this we will call as a title, and this we will call as a subtitle. Then this detailings we have to show, like this is the wall. Okay, so we may write this the 30 centimeter thick wall. So this is the title, subtitle, and this is called the detailing. So this thickness of the letter, height of the letter should be smaller than subtitle. So this may vary from 3 to 5 mm, and this may vary from 5 to 7 mm. Suppose you have chosen the letter height for the title is 7 mm, so then you should choose the letter height for the subtitle equal to 5 mm, then letter height for the detailing should be equal to 3 mm. Okay. So always it should be in the decreasing size. So these are the different methods of doing the showing the dimensions. So you can show the dimensions by arrow. And again, arrows are also different shape, and this type of arrows. Okay, you may write this equal to 300 centimeter, or you may write, you may show the dimensions like this, 300 centimeter, or you may show this dimensions like this. You may put the dot here and dot here, 300 centimeter. If there is a very small size is there, like this wall thickness, so if you try to show in this style, it will be very, very difficult, because the width between two parallel lines is very less. You cannot put two arrows like this. Okay, in that case what is done, either you put the arrows like this, okay, and show the details like this. These are 30 centimeter. Okay, so these are the different ways of showing the dimensions. These two are the section lines. These are the section lines. Then again, in the drawing, sometimes instead of writing the full detail of the component or material, we use these abbreviations, short form of the material, like the cement concrete. We may use the CC, And for the cement mortar, we may use the CM, cement pointing. RCC is a reinforced cement concrete. CI is a cast iron. GI galvanized iron. GCI galvanized corrugated iron. The wrought iron. Expanded metal. Centimeter. M for meter. mm means millimeter. Square meter. Cubic meter. Teak wood, TW. CC, TW. Country cut teak wood. UCR, uncoached rubble masonry. CR, coached rubble masonry. RR, random rubble masonry. LM, the lime mortar. FDN, foundation. GL, ground level. In the central line, CC, the diameter. W, window. D for door. FL for flooring. Building use. BU, PL, plinth levels. SL, sill level. DPC, damp proof course. Then WC, water closet. Kilometer, km. Minimum, maximum. Then lintel level, LL. V for ventilator. FSI is the floor space index. Then PCC, plain cement concrete. BBLC, burnt brick. BB, burnt brick lime concrete. BBLC. BBCC means burnt brick. BB means burnt bricks. Cement concrete. So bricks are made from the clay, and initially first they are molded and they are dried. So if they are not burnt in the kiln, so they become the clay bricks, and after you burn it, you are giving the heat. So it is called the burnt brick cement concrete. The NO is for the number, ST is for the height, MS mild steel. So these are the different conventions which are universally accepted. So these are the symbols of the materials. When we cut the structure component, and if that component is made of, say, brick masonry, so this type of hatching is shown for brick masonry. If we cut a component, if it is made of concrete, so this type of symbol is shown. Here is properly, it's not because of this graphics is there, it's not proper. Actually concrete symbol, suppose if it's cut, so concrete is shown like this, the dots will be there, okay, small dots will be there, and these triangles are shown. So this is the proper symbol of concreting. Okay. In this slide it's not proper, but actually this type of symbol is used. So this shows the cement concrete is made of the water, cement, fine aggregate and coarse aggregate. So this dot shows the cement and fine aggregate, and this triangle shows the coarse aggregate, and this is universally accepted. This is everywhere this concrete symbol is used like this. Then reconstructed stone. Then stone masonry, here this for stone masonry symbol is not there. So for stone masonry, if you want to show the stone masonry, it is a 45-degree inclined lines are to be drawn. So this is called the stone masonry. In brick, this is a stone masonry. This I have drawn for the concreting. For brick masonry, the hatching is at the same degree. The hatching is at the 45-degree angle. Here also it is at the 45-degree angle, but there is a spacing between two consecutive lines. There is a larger spacing between two consecutive lines. So this is for the brick masonry. So when these symbols are shown, when the particular component is cut by the section, maybe vertical section or horizontal section. Otherwise we will not show this material. If it is only in elevation, brick masonry is there, these hatchings are not shown. So these are the different conventions for showing the windows and doors openings. So these are single leaf, single shutter. Single leaf means single shutter. Single shutter door is there, having this single swing. That means one is opening only in one direction, and this is the single shutter door which is opening in two directions, in inside as well as in the outside also. So double leaf, double shutter with single swing. Both these are the two shutters having swing, means movement only inside or outside, not in both the directions, either of one direction. These are double shutter door. Both the shutters are having the movement in both the direction, inside as well as outside. So this is for the revolving door. Many times you must have seen in the shopping malls or in gardens where we have to protect in garden we have to protect the trees from the cattle. Then we put this revolving type of the door. So person can enter by revolving this and can enter by standing in these gaps and moving along this the revolution when it rotates, and can come inside and outside. The sliding door, when space is very less, okay, because this when doors are sliding, then they occupy large space of the floor. To save the space, sometimes the sliding doors are used. Sometimes for the arrangement of the furniture we may need a larger space in the room, so we may put the sliding door. Then rolling shutter, you may have seen this rolling shutter which roll on the a rod is there. On that rod this shutter will be rolled when it is open, and it will be unrolled when it is closed. It is vertically moving up and down. Then the stair is mentioned like this, and here we should write the up. Actually stair is drawn like this. If the stair is to be drawn like this, so if it is a stair, the steps, okay, each is rise and tread, and this is the direction, and we should write here U, up, okay, the direction of going up. Then this is the window, and these are the window is comprised, doors and windows are comprised of the two components. One is called the frame, another is called the frame is the fixed with the walls, and another component is the shutter. Shutter is fixed on the frame. Shutter is the movable part. Okay, to open or close we will use the shutter. And this is a cupboard. The last item is you can show the cupboards like this. And these are the different symbols used for the different services. So in any building, first we have to create the structure. The structure means it's having the structural components like the foundation, substructure, superstructure. Then it will have the doors, windows, lintels, slab. Okay. After that we have to put the services. Services means we have to services means water supply, drainage, and then electrification. So we have to prepare the service maps also. So preparing the service maps, service plans, we have to use the different symbols for water supply, for drainage, and then electrification. Okay, that those drawings are also given to the plumber to complete the pipe network for water supply and drainage, and to the electrician to complete the wiring and cabling of the electrification for various appliances which are used in this building. So this is today we have covered the what is drawing, what is the importance of the drawing, then what is the engineering drawing. We have seen that drawing is not only for mechanical or civil engineers. It is very useful to each and every engineer and every professional who is involved with manufacturing and involved in the communication of these details to other person. So then we have seen what are the different aspects which the drawing, that is the visualization, then the tools which are used, then geometry and graphics which we will be using. Yes. So then we started with the different tools. We have seen the drawing tools: mini drafter, T-square, then protractor, divider, compass, eraser, pencil. Then we saw the different types of drawing boards, different types of sheets, then different types of pencils which we use. Then we have gone through these different conventions. Conventions means these norms or criteria which are followed everywhere, universally followed. That what should be the layout, what should be the margin of the desk, how we have to select the scale, and then different types of dimensioning methods, how to draw the north, what is the importance of the title block, and then these different symbols of the materials in section, and the symbols of the openings, and now these water supply, drainage symbols. So in next lecture we will be covering the remaining symbols and how to draw the plan section and elevation. Okay, so that is very very important. That is called the working drawing, or also known as architectural drawing. In architectural drawing, we already seen in the bottom we show the plan, and above exactly that we prepare the elevation, and very near to the elevation in same line we have to draw the section. Okay, thank you very much.